So Mr. Orski started out this unit with a bunch of demos, but to understand those demos, you have to know kind of the laws that apply to those. So the first one is Boyles' law, and that is with pressure and volume. And so as pressure would go up, volume would go down, or as volume would go up, pressure would go down. They have an inverse relationship. And so that equation would be like PV, or P1V1 equals P2V2. So it'd just be multiply pressure times volume, and that equals the second pressure times the second volume. Then you have Charles' law, which is temperature and volume, and they have a direct relationship because the graph has a positive slope, and so as temperature increases, so does volume, and vice versa. Then next, you have Gay-Lussac's law, which is pressure and temperature. They also have a direct relationship. As pressure goes up, so does temperature, and as temperature goes up, so does pressure. And you can relate that one back to where she had a bottle, and she would pump gas and air into the bottle, and then the temperature in the bottle would rise. And then you have the combined gas law, where you basically take all three laws. It's P1V1 over T1 equals P2V2 over T2. And the last law is Avogadro's law, which is molar volume. We've learned that from when we did the mole unit, which 22.4 liters is equal to 1 mole. So some other demos she did was when she would talk about there would be two plungers and they would be stuck together, and would it be harder or easier to take those plungers apart at a higher altitude or a lower altitude? And it'd be easier to take apart at a higher altitude because inside the plunger there's almost no pressure. Inside there's still some, but there's not a lot. So when you go to a higher altitude, there's not as much pressure, so it's easier to pull apart those plungers. But if, say, you went into Death Valley, which is a deep part on land, and you tried to pull them apart, there's a lot more pressure pushing on those plungers, so it'd be harder to pull them apart. Some other things are when she did the demo with the egg, where she put the egg and it would sunk into the glass jar. It's because she put the egg in there and then she cooled the air in the jar with ice. And as temperature went down, the pressure went down. So there was less pressure. So there's a higher pressure outside the jar, pushing the egg inside. So that would be Gay-Lussac's law. So you have to remember, like, if you apply these laws to her demos, it helps you understand them better. Some other things she went over when I went to the review is, like, a barometer is a device that measures atmospheric pressure. And then when she was taking notes one day in class, she told us to star this. It's important that a Newton over a meter squared equals 101.3 kPa, which equals 1 ATM, which equals 760 millimeters of mercury, and that equals 15 pounds over inch squared. These are all conversion factors. ATMs is like used for pressure and other things. Just remember, kind of have to remember those conversion factors. They're helpful. Another conversion factor is 273 plus degrees Celsius equals Kelvin. So in a problem that involves temperature, you always have to add 273 to the amount of Celsius, and that'll give you the amount of Kelvin it is. And she's very specific. For all problems on the test, you have to write down the formula. So like PV equals P2V2, you have to write that down first. Then you substitute the numbers and the labels and show the answer. So after you write down PV equals P2V2, substitute in all the numbers, and then do the math like normal. Make sure you label everything because she's going to be very picky with all these problems. And she was also, I know she reiterated a lot that you want to circle the amounts as you're going through. So if you see like 3 ATM, you want to label that P1. If you see like 4 liters, label that V1. Go through the problem and label each thing so you can know how to set up the problem as you're going along. Some other things that were important is that, like, we live in the troposphere, but in the atmosphere overall, The two most abundant gases are nitrogen at 78.08% of the atmosphere and oxygen at 20.95% of the atmosphere. And two other gases that are not as common but she might ask questions on are argon, which is 0.83% of the atmosphere, and carbon dioxide is 0.033% of the atmosphere. So just in case she asks for two less abundant gases, those are two of them. They have some others in your book if you want to look there. Another important thing, which is also in your book, is it's on page 259 in your book. There are the postulates for gases that there are four different postulates. One is gas consists of tiny particles, atoms or molecules, whose size is negligible compared with the great distances separating them. Gas molecules are in constant random motion. They often collide with each other with the walls of their container or surrounding objects. Gas pressure is a result of molecular collisions with container walls and other objects. Molecular collisions are elastic. This means that although individual molecules in gas sample may gain or lose kinetic energy, there is no gain or loss in total kinetic energy from these collisions. And the last one, at a given temperature, molecules in a gas sample have a range of kinetic energies. However, the average kinetic energy of the molecule is constant and depends only on the temperature of the sample. Therefore, molecules of different gases at the same temperature have the same average kinetic energy. As temperature increases, so does the average velocity and kinetic energy of the gas molecules. These postulates kind of just go over some basic things that you need to know. That pressure is created from gas molecules moving around. So if you study these postulates and look through your book, that'll help a lot when you're studying. Then there's some math problems that we're going to go over, and one she went over in class is that you have, and this is also on the building skills, you have two circles filled with gas. The smaller one is filled with 0.5 liters of gas and is at 1 atm of pressure. Then there's split in between by a blockade, and the other one is 2 liters. It can hold, but there's no gas in it. So when you open that in between, that valve, how much pressure will be in this second jar, or the second circle? So set that up. Remember what you have to write down for all problems. Try and set it up. Label what each number is. Alright? So then first you write down PV equals P2V2. That is your first step. Then you write 1 atm, because that is your first pressure, times 0.5 liters, which is your first volume, equals 2.5 liters. Now why is it 2.5 liters? Because if you open this valve, that 2 liters plus that 0.5 liters is the total amount that is, since it's covering the whole distance. So it's a 2.5 liters is your second volume. Now since you're trying to find the pressure, that you can just put as question mark or X. So then what you do is 1 atm times 0.5 liters is 0.5 atml, which would be over 2.5 liters. So liters cross out, and 2.5 divided into 0.5 is equals to 0.2 atm, because liters cross out and you're left with pressure. So if she gives you one of these problems, remember that you have to add the two volumes, because the gas is going everywhere in this apparatus. All right, the next problem involves the equation. Now, when we did this equation first, it was all in moles, and it still is in moles, unless all the elements in there are gases. So C2H6 is a gas, so is oxygen, carbon dioxide, and hydrogen. So since they're all gases, you can just say that they're liters instead of moles. So the question is, if you have 3 liters of oxygen, how much CO2 in liters is made? So this is just a standard stoichiometry problem. You're going to take what you have first, your 3 liters of O2, and you're trying to convert into CO2 in liters. Now, if you don't remember that this is just liters, you can start with liters, convert to moles, and then convert back to liters using the 22.4 liters. It's 1 mole, which is Avogadro's law. Otherwise, it's a one-step problem. You just do 3 liters of O2, so 7 liters of O2, which is in the problem, up there, and then you have 4 liters of CO2, which is your last thing, liters and O2 cancel out, and you're left with 1.71 liters of CO2. It's a simple problem. And then we had this big lab in class where she went over how graphs have units. So slope equals m, and that's equal to y2 minus y1 over x2 minus x1. And we're just going to take, for example, your 2 points, because you can take any 2 points on the line. So your 2 points are 1 and 2, and then 3, 5. So you have 5 minus 2 over 3 minus 1. And we're assuming the graph that I got these off of were in miles an hour. So it would be 3 miles over 1 hour, or 1.6 miles an hour. Now, she might also ask you to calculate a straight line. So that formula is y equals mx plus b. So overall, it'd be, the y-axis was miles. So it'd be miles equals 1.6 miles an hour times hours plus 0 miles, because b is the 0. So all these, the math, I didn't give you too many problems on that because she gave us a lot of worksheets in class that you could practice. So go over, do those worksheets. To check, you should get these right. They're not too hard of problems. Check with the classmate who did them if you want to figure out the right answer. Make sure you review your chapter summary, which we did in class. Do the building skills again. The test is going to be long. There's a lot of material on it, but she gave us all the things we need in our notes and in the book to study. So, and she gave us a lot of worksheets in class to work on these. If you have any questions, I'll be able to answer them. Contact me, and that's it. Good luck.